So, if we observe what's happening in the market today, particularly with the disruption in AI, the best structural analogy is really electrification. And that analogy was the electrification of the American industry between 1882 and 1935. And the diffusion of artificial intelligence has a lot of parallels with it, which is happening and we're defining as between 2018 and 2030, even though artificial intelligence definitely precedes 2018 with rules-based machine learning and neural networks, et cetera, right? The central argument is that first formalized by the economist Paul David in 1990, and it's that general purpose technologies follow a predictable pattern, that you have rapid capability demonstration, and then there's a prolonged organizational adaptation lag. And that is kind of what we're seeing today. It is definitely what we're seeing today, as you could see that there's been adoption, but the productivity gains have not materialized. And there is a lot of parallels with what happened with electrification. Here, you see the adoption curve between in comparison between AI and between the AI transition. Now, the adoption curve is expected to be much faster in terms of productivity gains compared to electricity, but there's definitely a lot of parallels with that. Now, when we look at tech diffusion, the thing to look at is what's called the S curve, and the S curve is essentially the adoption curve. And the adoption curve is similar. There's faster adoption of AI compared to electricity. However, the productivity gains from electricity and the productivity gains from AI has a lot of parallels, right? So if we look at the productivity gains, which is measured by what's called total factor productivity, it's an economist term for looking at what the measure of total productivity gains are attributed to a certain sector, in this case being AI. There's a lot of parallels. So you could see that in the case of electricity, even though electricity was implemented, it came out in the late 1800s. It wasn't until 1920 when factories were finally redesigned and the productivity gains were made. And you could see the same thing happening with AI, but under a compressed time frame. So with AI, there's been massive amount of level of AI adoption. You could see that adoption is occurring at an unprecedented rate. However, the total factor productivity, the productivity gains associated with AI have not been captured. And the reason that that is, and I will show you through the historical analogy and what's actually happening, is the fact that organizations still need to change the way that they adapt. Their organizational structures need to change. And you will see how the case of electricity, this actually happened and why that lag occurred. Now, we can even run a model here to show that productivity realization on what we're likely to expect when it comes to AI. So there's been a lot of adoption of AI, but you could see that the productivity gains are not yet being captured. And if it was a historical prior, right, you could see that the productivity gains are going to actually be captured a few years down the line. I'll show you why. It's because the organizational structure needs to adapt to capture those productivity gains. But even if we look at it on an optimistic fast track, in this case, we're simulating 1,000 alternative futures to show what an optimistic productivity adaptation would look like. You could still see that it still has a lag, right? Now, the people that are going to win, the organizations that are going to win, are not going to be the organizations that might have the most powerful AI models per se. Everybody's going to have similar models. However, it's going to be the organization that can adapt and gain those productivity gains. Now, why is the lessons learned from the advent of electricity really important in this analogy? Well, let me show you. Okay. Now, when electricity came out, what happened is people started adopting electricity, but the factory floors did not transform. So you could see that it was still what was called a steam shaft factory. So the layout was still the layout associated with the steam engine. So the steam engine was replaced with an electric motor, but the central overhead steam shaft had all machines clustered to the steam engine layout. And so as a result, those productivity gains were minimal. It was like maybe 2%. One large steam engine driving a single overhead shaft spanning the entire factory floor. Every machine was connected via leather belts. So you had electricity, but the factory floors and how things were being produced did not adapt yet to the possibilities of single motor electric engines. And that was the mistake. The engine was replaced, but the shaft was kept. The structure was kept, and it resulted in just a 2% gain. And that 2% gain persisted for years. Factory owners swapped the steam engine for the electric motor, like what we're seeing right now with AI. People are adopting AI. There is productivity gains being made at the individual level, but then they connect it to the exact same overhead shaft. And today, organizations have not yet made that transition. They're still operating under the same structure, but implementing AI and not adjusting the organization to the changes associated with the AI. Analogously, it's the same overhead shaft and it's the same belt, the same floor plan. And it failed in gaining productivity because the organizational architecture did not meet the potential for the electrical motor until years down the line. Now, this is the same analogy in terms of labor at scale and human headcount, right? The universal architecture, whether it's a bank processing loan applications, an insurance company handling claims, logistics, hospital managing records, every operation is structured around human labor organized into process tiers, workflows through a headcount hierarchy, not necessarily the value logic. There's organizations that are doing it, but they have not adapted yet. And the business model across industries still remains output volume times human labor hours and how people are utilized. So whether it's manufacturing throughput or claims being processed, transactions cleared, or cases resolved, headcount is still a primary input variable. So cost reduction historically meant wage arbitrage or offshoring, and that is changing. Why is that changing? Because of the process clock, right? Cycle times, loan approval, claim settlement, whatever the process, human processing capacity is at each stage. So speed historically has meant more people, and throughput has historically meant more headcount. Even though we might be incrementally reducing the headcount, it is highly correlated with headcount. And the process design is dictated by what humans can handle at each stage, whether it's a batch size or reviewing queues or handoff protocols, you name it, right? So what's going on with AI is we're seeing a 3 to 10x increase faster at the task level, but we're not seeing that translate yet at the firm level, right? Because our firms and organizations are just in the early stages of changing their organizational structures to meet the full value of AI, okay? So what does that mean in terms of AI tool layering, right? So if you look at AI tool layering, right, by and large, most organizations remain unchanged. The worker enters the queue. There's a human batch processing, hierarchy review chain. There's a reporting and compliance, a manual quality check, delivery to next stage. These things are being automated, but they're not being automated, redesigned organizationally in a radical way yet, right? So it's the same type of thing that you're seeing across agencies, right? Same types of processes. The tool is swapped, but the organizational architectures remain unchanged, right? Now, where those gains disappear, the 25% task speed gain, right, which could be absorbed by unchanged handoff protocols, unchanged approval chains, unchanged back processes. That speed at one node doesn't change the system throughput when the bottleneck remains the structure. It's not the task, right? And there's ample evidence. The evidence shows, based on NBER paper, right, National Bureau of Economic Research by Yatsov et al., 90% of firms report um, zero firm level productivity gain from AI, despite documented task gains, right? Of 25% increase in speed and 40% increase in quality. That's because analogously, the factory floor setting that we saw during the electricity age, the implementation of electricity, analogously has not changed when it comes to organizations implementing AI. So, what does that mean, right? What that means is that we need to go from centralized shaft to distributed AI agents, right? Where the requesters enter systems, AI agents execute, humans at the frontier are only for human type tasks that are novel decisions, the outcomes are delivered, and the system improves. So this changes from where we are today because we go from centralized systems to distributed systems. And those distributed systems is exactly what happened with electric motors. Electric motors over time got distributed because factories found out that, like, hey, we don't have to have this rigid centralized process. We could have a lot of different motors and set up the process for whatever is appropriate for the queue. Similar type of analogy when it comes to AI, right? Each stage in the process can get its own AI agent: intake, classification, transaction processing. So there doesn't have to be central labor bottlenecks. Each stage can run independently at machine speed. But the org structure needs to be rebuilt around work and not around the head count. And output follows value logic, not process hierarchy. There are examples in which there's cross-industry evidence. JP Morgan, a lot of evidence publicly reported on JP Morgan's coin system, UPS's Orion AI routing system, et cetera, but it has not been implemented widely. Now, people are then asking, what about humans? Does this mean that there's going to be a job apocalypse? Not necessarily, right? There it will be room for humans, and there will be extra value on humans, but the type of work that humans are going to be conducting is different. And the head count is going to be determined by how organizations adapt organizationally. Now, what do I mean by human judgment at the frontier, right? When the organizations are reorganized, enterprises move humans out of the pipeline of routine, mundane, or what they call homogeneous labor pools onto the frontier. Now, what does the frontier mean? It means edge cases, novel situations, ethical decisions, relationships, things that AI cannot yet handle because at the end of the day, humans still have to make decisions. But it's going to be distributed, like a distributed motor. And humans are the most valuable where AI is weakest, not where AI is strongest. So, what are the structural parallels? Okay. Here's the structural parallels. Okay. Central organizing resource, right? During the electricity boom, right? It was the steam shaft. Every machine positioned by proximity to power source. The layout equaled the shaft geometry. In the AI transition, it's human labor hierarchy. Every operation structured by processing capacity as each tier. And so the throughput equals the headcount time times the hours. And that becomes the limiting structure towards productivity because it's not caught up yet to the potential of AI. The first mistake was that during the electrification era, electric engines were replacing steam engines with electric motors, but the shaft remained the same. They kept the same floor plan. So the gain, as I mentioned earlier, was only 2%. With AI transition, it's similar. You have deployment of AI, right, on onshore teams. You have offshore teams using AI, but it keeps the process hierarchy and it keeps the headcount based on capacity planning. So firm level gain is not that high, even though there's individual level gain. Now, what that resulted into is a productivity paradox. In the case of electricity, it took 26 years between the time that the technology was adopted in 1882 and total factor productivity acceleration, which happened in 1916. And this is documented by Paul David and others. Paul David in his uh, uh, seminal work in 1990, right? In the case of AI, the evidence shows that there's around a 3 to 5 year lag, that task gains result in 25% speed and 40% quality by Delacqua, the seminal peer review publication by Delacqua in 2023. But firm level remains minimal for 90% of companies because that organizational structure is not caught up yet. What's the mechanism lag? It was factories had to redesign layouts. Today, organizations have to redesign their process architecture, capacity model, talent, because talent is more about the density of talent rather than a pyramid. And that means sequential investment can't be skipped. The breakthrough was distributed motors. And for this age, it's going to be distributed AI agents embedded in operations. There's people that are doing it right today, right? But there is a lag like there was during the electrification era. There's a labor market signal, gas lamp workers and steam fitters, 85% employment, 1890 to 1930. Electrical engineers resulted in 38% wage premium throughout that 20-year period when it started taking off. And you could see the same happening with a premium on highly skilled AI workers today. There was platform concentration back then. The platform concentration, there was 8 utility companies controlled electricity. 72% of US electricity power by 1928 was GE and Westinghouse, 80% of the equipment market. You have a similar type of condition with the hyperscalers, AWS, Azure, Google, 65% of cloud infrastructure. Top 3 foundation models account for more than 85% of enterprise deployment. That's okay, because just like when there was electricity, it wasn't necessarily how many electricity companies are there. It was more about what gets built on top of the grid that accelerated growth and human ingenuity and progress. The timeline compression during electricity was 47 years. We don't have that timeline today with AI. It's 12 to 15 years projected conservatively. So that's about three and a half times faster due to the digital distribution, zero installation cost, network effect, et cetera. And the adaptation window is really 3 to 5 years today. In that adaptation window, you'll continue to hear things about that, about density of talent, about forward deployed engineers that you could see. Palantir has done a great job in developing. Databricks and industry, including services segment, are adopting that as well. So what should firms do? The same answers as 1910. 1, identify the frontier. What is it that humans can do well? What is it that humans can do well better than AI? How can they work with AI as human enhancing tasks and not just pure task replacement, even though that's taking place? 1. 2, you got to redesign that process architecture. 3, act within the window, right? If we act within the window and you can change your organization to capture those gains with the opportunity related to AI, you will succeed. If the organization cannot adapt, it's gonna get left behind. The last time a general purpose technology restructured the global economy, the firms that won weren't the ones that adopted it first. They were the ones that reorganized around it and were able to implement. Thank you. This concludes my talk. Hope you enjoyed it.